Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about infinite Fourier transforms. In detail, we will discuss the definition of infinite Fourier transforms, problems on infinite Fourier transforms. The definition of infinite Fourier transforms. That is, the Fourier transform formula is capital F of x. That is, mathematically, the notation is capital F of x. We will read the capital F stands for Fourier transform of the function f of x. We can write in another way, capital F of p is nothing but integral of e power ipx f of x dx, then the limit from minus infinity to infinity. Inverse Fourier sine transform formula, if we do the comparison of Fourier transform and inverse Fourier transform, here the function f of x is coming out from the integral. That is an easy way we can remember the inverse Fourier transform formula. So f of x equal to 1 by 2 pi integral minus infinity to infinity capital F of p e power minus ipx dp. So the difference between the Fourier transform is integration with respect to x, whereas inverse Fourier transform, the integration with respect to p. Our topic is infinite Fourier transform. The infinite, the word only, it is not there in both the formulas. By default, if it is not given, it is understood that it is infinite. If you are noticing integral, the limit is minus infinity to infinity. That's what it is, infinite Fourier transform. If we are writing infinite Fourier transform or only Fourier transform, it represents infinite. Fourier sine transform formula, that is capital F, if it is only f of x, this we are very familiar, that Fourier transform of f of x, but here a small s is written here, then it is Fourier sine transform of the function f of x. In another way, capital F s of p equal to integral 0 to infinity f of x sine px dx. Inverse Fourier sine transform formula is f of x equal to 2 by pi, that is the f of x, it has come out, 2 by pi integral capital F s of f of x sine px dp, the integral from 0 to infinity. Fourier cosine transform formula, that is capital Fc of f of x equal to capital Fc of p, is the formula integral 0 to infinity f of x cos px dx. Here also to be written 2 by pi. No, it is correct only, integral 0 to infinity. If it is inverse Fourier cosine, then 2 by pi will be written before the integral. Yeah, it is written here, inverse Fourier cosine transform formula, the f of x, the function, it has come out. So 2 by pi, The Fourier cosine will go inside. Easy way we can remember. Cos px dx. So this everything infinite Fourier transform along with inverse formulas. Only Fourier sine, Fourier cosine, they are integrated with respect to x, whereas inverse Fourier sine, inverse Fourier cosine, all are integrated with respect to p, they are multiplied. If it is inverse Fourier e power minus ipx, we have to do the comparison study, then it is easy to memorize. So now, based on these formulas, we will solve the problems. The first problem is, find the Fourier sine and cosine transforms of, the first question is x power n minus 1. The second question is 1 by root x. These two sums we have to solve Fourier sine and cosine transform. There is no word about infinite. That's the reason the before slide explaining only. By default, if it is not given, we will use infinite Fourier transform. Because another one, finite Fourier transform also it is there. This video lecture we are concentrating on infinite Fourier transform. First we will solve this function, that is our f of x, that is given x power n minus 1. Solution is Fourier sine transform formula, because we are asked to find Fourier sine. So the Fourier sine transform formula is capital F, S of f of x equal to integral 0 to infinity f of x sine px dx. So we have to do the integration with respect to x, the limit from 0 to infinity. That is a Fourier sine transform. Fourier cosine transform, the difference between Fourier sine and Fourier cosine is nothing but s is replaced. Sine is replaced. Sine replaced by cos. Here s is replaced by c. So now Fourier sine formula is ready. Fourier cosine formula is ready. These two we have to apply the first problem. The function is x power n minus 1. So we know it. This is the Fourier sine transform and Fourier cosine transform. We will apply. Our function is x power n minus 1. That is the f of x. It is replaced by our x power n minus 1. So here we can notice it. Here fs of, this is our formula. Fourier sine transform formula. F of x is our given function. Our given function is x power n minus 1. So f of x is replaced by x power n minus 1. Here also that f of x is replaced by x power n minus 1. The sine px is written as it is. The dx is written as it is. Just we replaced in the formula where f of x is there. That particular f of x is replaced by our given function. Sine transform, the work is completed. Similarly now, Fourier cosine transform we will focus. So where f of x, fc of f of x replaced by x power n minus 1, integral 0 to infinity. As usual, f of x is replaced by our function. That's what it is written here. X power n minus 1 cos px dx. The first one, that is f s of x power n minus 1, we named it as equation 1. fc of x power n minus 1, we named it as equation 2. Now, the question is, this is the function. For this function, we are asked to do Fourier sine and cosine transform. What we are going to do, separate, instead of doing separately, we decided to combine these sine and cos. We are going to take the problem solution in a different way. That is, keeping in our mind a formula, it is there, e power I theta, it's nothing but cos theta plus I sin theta. So this formula, it is striking in our mind, keeping in that, instead of doing equation 1 separate solving, equation 2 separate solving, avoiding that, this formula help taking, we executed this way, that is, equation 2 is added with equation 1, whereas the equation 1 is multiplied by I. Yes. Now, equation 2 is here. So we can see it here. The equation 2 is multiplied is by 1. That's what it is written here. Whereas the equation 1 is multiplied by I. That means here I is there. Here also I is there. Both the side. Mathematically, if we add, subtract or divide anything, the operations, we have to do both left and right. We have to balance the equation. So, here equation 1, left and right, we multiplied and we are going to add. This, it has come. Now this is, it has come here. Now this part, it is written as it is. This part is multiplied by I. That's what here. I sin px. In this both the term x power n minus 1 is common. We have taken outside. So this is the background, the idea to execute this one. According to the formula, e power I theta is cos theta plus I sin theta. Our problem, cos px plus I sin px. So the px is our theta. So we can write it, integral 0 to infinity as it is, we wrote it. This x power n minus 1 we didn't touch at all. As it is, we wrote it. But this part, cos px plus I sin px, that we have written e power I px dx, we wrote it. So now we have to do this integration. So it's a very, what is that, how to do this integration? Methods are there, but easy way, substitution method. That is, in terms of x it is there. And the integration is done with respect to x. Completely with respect to x it is there. We are going to change with respect to t, substituting some term. IPX, we have taken minus t. We are differentiating both the sides. That is, IP dx, x differentiation is dx, minus as it is d is dt. When the substitution method occurs, we have to check the limit. Is there any changes are there or not? Our limit, that is with respect to x, we are doing the integration. The limit from 0 to infinity. When x equal to 0, what about t? We will substitute in the place of x 0. Then t is becoming 0. When x equal to infinity, what about t? T is also 0. Now 0 to infinity, fine. E power ipx, what we assumed it, minus t. X, what is x? From here we can get ipx equal to minus t, x equal to minus t by ip. That's what here it is written. This power is n minus 1 is as it is. Dx, from here we can get it minus dt by this ip will come here. It is substituted here. Compare the before integral, the recent integral, the before integral completely in terms of x. Now we changed in terms of t, completely we changed it. Simplifications, e power minus t as it is. Here a by b power n. Exponential law, a by b power n, it's nothing but a power n by b power n. This law, using our minus t by ip, the whole power n minus 1 it is there. So a power n, so b power n it is written. This it is written minus dt by ip. Now integral e power minus t, this minus t power n minus 1, ip power n minus 1 minus dt by ip. This is actually the previous, the slide, what is the last step, it is written again. This simplifications, how it has taken place. We can see it now. This term is written as it is. This term, just we will see, circle it. What are the terms are written as it is? This one. This is also written as it is. These are the terms we didn't touch at all. But whereas here this minus t power n minus 1 is there, that we wrote it minus t, we can write it minus 1 into t. Mathematically it is correct. Minus t can be written as minus 1 into t along with that power. The power is n minus 1. That's what here we applied it. From here, this term also minus dt by ip it is there. From there, we have taken the minus 1. Minus we have taken means it is mathematical minus 1 we are taking out. Now, this e power minus t as it is. This term, what I am circling as it is. Dt is as it is. This minus 1 power n minus 1 it is there. But here the next step, minus 1 power n only it is there. Why we missed this minus 1? That is a correct doubt it should ring in our mind. So, minus 1 power n minus 1 we splitted in such a way minus 1 power n into minus 1 power minus 1. We can write it. That is also the exponential law. A power mi plus n, we can write a power m into a power n, we can write. Using that we did. This part, it has come out. So minus 1 power minus 1 is there. It's nothing but, we can write it minus 1. So from here, this term minus 1 is there. Here also one minus 1 is there. Minus 1 into minus 1 plus 1. That's what it is not seen in the next step. Remaining all the terms we have written as it is no. Here this term also IP power n minus 1 is there. Here IP it is there. We considered in the next step only IP power n only we considered. Then what happened? What we did? How we missed it? This IP power minus 1. So we can see it. IP power minus 1 is there. In this 1 by this term, IP minus 1 is there. Because the n it has come out. From here, 1 by IP. This we can write it 1 by a power minus m can be written as 1 by a power m, we can write it. All the laws are we studied in lower classes. That is same. This can be written IP power 1 into 1 by IP getting cancelled. That's what it is not occurred in the next step. Now, so up to here, how we got it, clearly it is there. Minus 1 power n, but here the next step, it has become I power 2n. That is, the minus 1, we know it, I square, it's nothing but minus 1. So, the minus 1 is replaced by I square. The power is n. So, I power 2n. Here, IP power n can be written as I power n, P power n. Here, I power 2n divided by I power n. So, it is becoming I power n. This P power n as it is. This whole term, it's nothing but gamma. Gamma function. The starting only we assumed it minus t. That is also the doubt why we have to the substitution method. That is while we changed the integration with respect to x, completely we changed the problem with respect to t. For that we assumed minus t. Why? We can't take plus t. If we take plus t, this gamma formula we won't get it. That is the reason we have taken minus t. The gamma formula function is e power minus x, x power n minus 1 dx, it's nothing but gamma n. That is in terms of x it is there. Our problem in terms of t it is there. That's the difference. With respect to x formula, our problem with respect to t. So gamma n. So I power n, P power n, gamma of n. This I power n, we can write it in such a way, cos 90 pi by 2 plus I sin 90. It's nothing but I, because cos 90 is 0, 0 plus I into 1 is I. n is as it is n. P power n is as it is p power n. Gamma n is as it is gamma n. 1 by p power n is taken out. This n, it has come inside. So the pi by 2 into n, it is becoming n pi by 2 plus I sine n pi by 2 into gamma of n. Now, this full completely, we got the integration. So far, what we have done it. That is, the question is x power n minus 1. Find Fourier sine and cosine transform for this function, that is x power n minus 1. That problem only we are solving. For that, Fourier sine we have taken, Fourier cosine we have taken, Fourier sine we have taken. Both we did add. This is the left side. This right side, this integration only solving we got, this is the result. Now, equating real and imaginary part. Left and right, we are going to the comparison. Real part, FC here this is the real part. So it is written, see FC of x power n minus 1, this integration, the result we got it already here, this integration result only this one. The left side is this one. Real part it is this one. Here the real part is this one. That's what we put it here. Imaginary part with I, imaginary term in the left side is this one. We can see. Here this part is the imaginary. With that I, it is there. So now, the first problem, we have two divisions. The first one is f of x equal to x power n minus 1. We solved it. The second one is 1 by root x, it is there. One way we can do it, for this Fourier sine transform formula applying f of x equal to replacing that f of x equal to 1 by root x, we can do it in such a way also. That is also correct. But now x power n minus 1 using some result we got it. Why can't we use that result for this, the second problem solving? That is, this is the recently we got the result fc of x power n minus 1 equal to gamma of n by p power n into cos of n pi by 2. The next we got it Fourier sine of function x power n minus 1 equal to gamma of n by p power n into sine of n pi by 2. These two results we got it for the function x power n minus 1. The first part we completed. The second one, we are not going to take the direction of applying Fourier sine formula, Fourier cosine transform formula. We want to avoid that direction. Based on this problem result, is there any way? We are searching, we got it. The best way, putting n equal to 1 by 2. That is, here fc of x power n minus 1, it is there. In that place, n place, we are going to substitute 1 by 2. That is, x power n minus 1, x plus 1 by 2 we will put minus 1, it's nothing but x power minus 1 by 2 equal to 1 by x power 1 by 2 equal to 1 by root 2x. So FC of 1 by root 2x equal to, here gamma of n, both the sides. Here this is the formula, n equal to 1 by 2 we have to take. This side we substituted, we got it FC of 1 by root x. It's nothing but our second question. The right side, gamma of n, that is gamma of 1 by 2 by p power 1 by 2 cos of n pi by 2, that is cos of n place we are substituting 1 by 2, it's nothing but pi by 4. So Fourier cosine first we completed. Similarly, Fourier sine also to be done. So n place we are substituting 1 by 2, we know it. So before that we can see this simplification. That is gamma of 1 by 2, it's nothing but the value is root 2 pi. P power 1 by 2, it's written as root p. Cos 45, we know it 1 by root 2. The root 2 pi, it is written as it is. Root 2p into root 2, root 2p. Put together we wrote it root of pi by 2p. What the treatment we have given for Fourier cosine, the similar way we have done it for Fourier sine also. So Fs of 1 by root x equal to gamma of 1 by 2 by p power 1 by 2 sine 45. Sine 45 we know it, 1 by root 2. Gamma of 1 by 2 equal to root 2 pi. P power 1 by 2, it's nothing but root 2 p. It's totally we are getting root of pi by 2p. This is also a basic formula. Root a by root 2b can be written as root of a by b. So Fourier cosine of the second function 1 by root x, Fourier sine of 1 by root x, both are this one, both are same. So we completed the first problem, 2 parts for the function of x power n minus 1. With that result, what we derived it, with that help, the second part also we completed. The next problem is find the Fourier sine transform of e power minus mod x and hence evaluate integral 0 to infinity x sine mx by 1 plus x square dx. Solution: Fourier sine transform. Clearly already starting onwards I told. Our topic is infinite Fourier. But in the question there is no word at all infinite. If it is not given, it is infinite. For the function we have to find. Our function is e power minus mod x. So the function taking Fourier sine transform formula we will apply and we will do it. But one more also they are telling, evaluate this integral. Sine is there, x is there, sine mx is there. It is not at all relevant to our so far what we discussed it. So it is this problem, how to solve, we will do it now. So the given the function is f of x equal to e power minus mod x. The Fourier sine transform formula is, we can see it here, capital F S of f of x equal to integral 0 to infinity f of x sine px dx. So 0 to infinity e power, that is f of x, is replaced by our function e power minus mod x sine px dx. So integral 0 to infinity. Now the minus sign, it is written as minus, same we reproduced it. Whereas mod x is written as x. Is there any rule? Yes. If the limit from 0 to infinity, mod x is strictly x. That is the reason mod x is replaced by x. The minus sign as it is, we retained it. Sin px is sin px dx. This integral, we have to do it. We have the formula for exponential and trigonometric. Combined the formula, it is there. That is e power ax sin bx dx equal to e power ax by a square plus b square of a sin bx minus b cos bx. This is the formula for the exponential and trigonometry combined one. What about our problem? E power minus x sin px dx. Here our a is, in our problem, minus 1 is there. B is, p is there. This keeping in our mind, without committing any mistake, correctly we have to substitute. So we substituted e power minus x, that is e power our ax. Formula e power ax, a plus we substituted minus 1, it has become e power minus x. Formula a square plus b square is there, a square, it has become, our a is minus 1. Minus 1 the whole square is 1. Plus b square, it is nothing but p square. So a is minus 1. So minus sin px minus b is p cos px. 0 to infinity. Here e power minus infinity, the value is 0. E power 0, the value is 1. X place we are substituting the infinity, we got it. The upper limit is infinity, we substituted in the place x, upper limit it has become 0. So totally in this place we substituted e power minus infinity, completely it is vanished. This is the formula minus upper limit minus lower limit. The lower one is 0. So e power 0 is 1. 1 by 1 plus p square. Here x place we are putting 0 because we did the integration with respect to x. So sin 0 is 0 minus p, cos 0 is 1. So p into 1 p, that's what here, minus p by 1 plus p square it is written. This minus, it is becoming plus. Final, we got it, p by 1 plus p square. So the question is, for the function e power minus mod x, find the Fourier sine transform. But evaluate some integral part also it is given. So we can't stop the problem solution up to here. We have to proceed more. For that, we are taking the help from inverse Fourier sine transform formula. Wherever the formula, they are taking place, the function f of x will be coming out. The Fourier sine will be inside the integral. So, 2 by pi integral 0 to infinity Fourier sine of f of x. Our f of x is e power minus mod x. That result only just now we discussed, we solved it. That in the previous slide. This is the result we got it. P by 1 plus p square, and sine px is as it is, dp is as it is. So now we can say it. We can't stop up to here. What is evaluate? Evaluate the question 0 to infinity x sine mx by 1 plus x square dx. But our last step is this. There is no connectivity at all. We can't stop. It gives an indication that more steps are there to reach this integral result. So we have to proceed more further. We will do the comparison. Here dp is there, here dx is there. Here p square is there, here x square is there. Here p is there, here x is there. Here sine px is there, here mx is there. So what are the variables differences are there? Just we are doing the comparison. We have to do the comparison because this is the result we have to get. So we are doing, so now our f of x is e power minus x. Because e power minus mod x only is our question. But this we discussed, 0 to infinity means the mod x is what? X. So e power minus x. Our f of x is e power minus x. This is written as it is, remaining all as it is written. Now, in this, wherever x is there, that we are going to change it into m. Suddenly, why the idea? It is not any big idea. We have to get, this is the question they are asking us to do. In the question, m is there. But what we are doing, the procedure, there is no sign of m occurring. Better we can take this x, we will change into m. But mathematically, if it should be correct in the sense, whatever we are doing, the changes to be done both left and right, then it is correct. Then it will balance the equation. So, left and right, both the sides, wherever x, we will change into m. Why we have to do? Only the answer is to get this integral. So we put it here. Here x is there and here x is there. So the particular places I am circling. So both the left and right side x, it is changed into m. Yeah, we changed it, but this we didn't reach at all. Integral 0 to infinity, it is there. Sine mx is we want, but sine mp is there. We want 1 plus x square, but here 1 plus p square is there. Dx is there. We want a dx, but here dp is there. Here x we want, but p is there. We are noticing mx we want, but here mp it is there. So, everywhere we want x, but everywhere we have p. Better replace that p by x. So, the replace by p by x. Left is e power minus m. This 2 by pi integral 0 to infinity So x is replaced, p is replaced by x. 1 plus p square, it's nothing but 1 plus x square sine mx dx. It is as it is, 2 by pi. This format we want it because this is the evaluate integral. Same format we are bringing. X sine xm is there. Sine mx we can write it. 2 3s are 3 2s are, both are same. 1 plus x square dx. So complete, this is only, it is matching. Then the 2 pi by, we will push it to left side. Then 2 by pi, it is becoming here pi by 2 e power minus m. So the question, it is very clear. This they asked us e power minus mod x. We applied infinite Fourier sine transform formula. We didn't stop because one more part also it is given. Like that, if any more integral, any value they are asking, then what we have to do, the relevant inverse formulas we have to take help and we will be reaching the answer. For that purpose, this problem is explained in this video lecture. The next problem is find f of x if its Fourier sine transform is e power minus ap. The solution is, there is no word, the question if you read very clearly, inverse. Find f of x, it is given. That means the function is out. It's a Fourier sine transform. The meaning is fs of f of x is given. It is, this complete meaning is, we have to read the question once, twice, especially this Fourier transformations. There is no word inverse apply, but they have given indirectly. Find f of x, they told. It is understood that inverse we have to apply. Fs of its Fourier sine transform. That means capital Fs of f of x is given, that is e power minus ap is given. So the f of x equal to 2 by pi integral 0 to infinity capital Fs of f of x sine px dp. We know very well the inverse compulsory, the integration with respect to p. So the f of x we have to find 2 by pi integral as it is. Fs of f of x, it is given in the question. It is replaced, that is e power minus ap sine px dp. Now 2 by pi e power minus ap sine px dp. This is the formula. That is a combination of exponential and trigonometry. That is e power ax sine bx dx. It's nothing but e power ax by a square plus b square of a sine bx minus b cos bx. Formula with respect to x, it is done integration, whereas here it is done with respect to p. So complete formula, where is x? Our in the problem it is playing the role p. A in the formula, whereas our problem minus a is playing the role. Then what about b? B is playing the role x. This is only very, very important problem and formula comparing the variables, what is the role they are playing. That finding, afterwards we have to substitute. Substitution should be started. Now, this 2 by pi written as it is, e power ax, our a is minus a and ax. Formula with respect to x integration, our problem is with respect to p. So e power minus ap divided by a square minus a the whole square, it's nothing but a square, plus b square, it's nothing but x square. Then a is minus a sine bx, our b is x is p. Next, b is x cos px 0 to infinity. Now 2 by pi, e power minus infinity is the value is 0, e power 0 the value is 1. We are substituting the upper limit, that is infinity. So e power minus infinity, the upper one is completely vanished, formula minus. The lower part is 0. So e power 0, the value is 1. So 1 divided by a square plus x square into, here substituting, we got it 0 because sine 0, the value is 0, minus x cos 0, the value is 1. So we got it 2x by pi of a square plus x square. Yeah, we will come to a conclusion of this topic, infinite Fourier transforms. First, we discussed the definition of infinite Fourier transforms. Fourier transform, inverse Fourier transform, Fourier sine and Fourier cosine along with their inverse transforms. We have taken the problem, that is Fourier sine and cosine transform for the functions. The first one is x power n minus 1. With that help, the function 1 by root x is solved. It is discussed in detail. Each and every steps it is explained in this video lecture. The next one, the different problem. Find the Fourier sine transform of e power minus mod x. From that, how to evaluate the integral 0 to infinity x sine mx by 1 plus x square dx. That is, with this help, if it is evaluate any integral comes, we have to use inverse. The last problem we discussed, that is indirectly it is given. There is no word about to apply, that is inverse, but it is written find f of x. It gives an indication that we have to take the formula, inverse formula. So we discussed in detail about infinite Fourier transforms. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.